Here's a quick video about how the unit circle and sine and cosine are related. When I first learned trigonometry back in high school, I was first taught about right triangle trigonometry and actually spent a long time learning about it before anyone ever told me about the unit circle and how it relates to cosine and sine. And once I learned the unit circle, everything made so much more sense. I had to memorize so much less. So I want us to actually start with the unit circle. Now the unit circle is defined by this equation. X squared plus y squared is 1, and that gives us a radius of 1, which is why it's called the unit circle. A unit is 1. And I've drawn a picture here where you've got an angle T in standard position, and it crosses the unit circle at a point, for this picture, in the first quadrant. Now that point defines cosine and sine. Cosine is the x value of the point, and sine is the y value of the point. That's it. That's the definition of sine and cosine. So let's look at an example. And let's go ahead and draw an angle. So we've got the terminal side there. Let's say that we know that the y value is 0.9 for some reason, but no one actually told us what the x value was of that terminal point. Well, we can actually figure it out using the equation of the unit circle, the x squared plus y squared equals 1. We go ahead and plug in 0.9 for the y and solve, and since it's a quadratic, of course we get two answers. Notice the answer that we want is the negative one because we want x to be negative in that second quadrant. So we know that it's actually negative 0.44, comma 0.9. And more importantly, for our topic right now, if we call that angle theta, that's in standard position, we know that the cosine is the x value of that terminal point, so that cosine of that angle that's drawn in there is negative 0.44, and the sine is the y value. Sine is 0.9. That's the basic idea. The picture tells the story. Now what's really nice about this is for the easy angles, there is absolutely no memorization other than the fact that sine is y and cosine is x. So that works for all the 90-degree angles, all the multiples of pi halves. If I care about finding the sine of 3 pi halves, we just need to actually draw the angle in standard position. I went ahead and drew that angle in blue. Notice its terminal point is 0, negative 1, and the sine is the y value. So our sine of 3 pi halves is negative 1. Let's do another one. What about cosine of negative 2 pi? Well, remember, negative is in the clockwise direction. So there's my angle, negative 2 pi. And its terminal point is this guy right here, the 1, 0. Now cosine is the x value. And so, of course, cosine of negative 2 pi is 1. Zero memorization. It's all in the picture. Let's do one more. What if you're asked about the cosine of pi halves? I should have made that pi halves green, but you get the basic idea. There's the angle pi halves in green. Its terminal point is 0, 1. And the cosine is the x value, so the cosine of pi halves is 0. And that's it.